Hello and welcome. Grab a coffee because today we're talking about synthetic data in machine learning, when it's a game changer and when it quietly sets you up to fail. I watched another data team last month repeat a mistake I made years ago. They got excited about generating a pristine, massive synthetic dataset, trained a model that looked incredible in validation, and then watched it faceplant in production. I felt that sting in my gut because I've been there. Synthetic data has come a long way since 2020. Generative models are powerful now, but that power also makes it easier to misuse. Here's the core misconception. Synthetic data is not a replacement for real data. It simply can't be. It's fantastic for filling gaps, simulating rare scenarios, or protecting privacy. But if you try to make it your sole source of truth, you'll likely end up with a model that aces training and fails the moment it meets the messy, unpredictable world. Why does that happen? Because synthetic data is built on assumptions. Assumptions about how variables should relate, how distributions should behave, and what normal looks like. Those assumptions can be mathematically elegant and still miss what really matters. Subtle correlations, seasonal quirks, external shocks, the weird little edge cases that only show up on real users on a rainy Tuesday. I've seen synthetic datasets for e-commerce that perfectly captured price and demand, yet completely missed how weather, social trends, or a viral post can whiplash behavior overnight. On paper, everything was smooth. In the wild, it wasn't. So let's flip it. When does synthetic data truly shine? First, when real data is scarce or sensitive. Think healthcare, where privacy is paramount and the stakes are high. With roughly 82% of the world's population under some form of data privacy legislation now, you often can't move fast with raw personal data, and you shouldn't. I worked with a team on rare disease diagnostics, where the real cases were painfully limited. We used synthetic generation, seeded by the few real examples we had, layered in domain knowledge, and crucially, had medical experts validate what we created. That bootstrapped the early phases of model development without compromising privacy. The lesson: use synthetic data to get unstuck, but ground it in expert review and whatever reliable real-world anchor you can find. Second, edge cases. This is one of the biggest wins. Some scenarios are too rare, too dangerous, or too expensive to capture at scale. Autonomous driving is the poster child here. You want to know how your model handles a child darting into the street at night, in a thunderstorm, with glare from oncoming headlights. You can't ethically stage that, but you can simulate it. The same goes for once-in-a-decade network anomalies, financial black swans, or safety-critical failures. Synthetic data lets you stress test robustness before your model ever meets those events in production. Third, bias mitigation. A lot of historical datasets bake unfair patterns, underrepresentation, skewed labels, systemic bias. Carefully crafted synthetic data can help rebalance by amplifying underrepresented groups or decoupling spurious correlations. But it's not as simple as making totals equal. You have to understand the domain, the fairness definition you're targeting, and the risk of reinforcing exactly what you're trying to undo. I've seen teams increase bias by generating synthetic records that mirrored the original dataset's blind spots. Done right, synthetic data can support fairness goals. Done fast, it can backfire. Fourth, augmentation. Deep learning models eat examples for breakfast. In computer vision and language tasks, generating variations, new scenes, paraphrases, style shifts can meaningfully boost generalization. The trick is to complement your real data, not drown it. Synthetic augmentation can also give you richer perspectives for exploratory analysis and visualizations, helping you see where your model is brittle. Now, let's be honest about when synthetic data is a bad idea. If you don't already have a trustworthy real-world baseline, you're flying blind. If your domain is highly non-stationary, where the world changes faster than you can model it, synthetic assumptions age quickly. If your use case needs strict auditability and clear provenance, over-reliance on synthetic may create governance headaches. And if your generator is trained on a tiny, biased real dataset, you'll just bake that bias into a bigger, glossier artifact. There's also privacy leakage risk. Poorly generated synthetic records can be traceable back to real individuals. If you can't test for that, pause. All right, let's get practical. Here's a simple playbook to keep you out of trouble. Start by defining the job. Are you using synthetic data to protect privacy, to bootstrap scarcity, to test edge cases, to balance bias, or to augment for performance? Pick one or two goals and write them down. Vague goals lead to vague results. Keep a clean, real-world holdout set. Never validate final performance on synthetic data. If your last mile isn't real, you'll be optimizing for the wrong game. Begin small and measure. Start with a modest proportion of synthetic examples. Think of it like seasoning, not the entire meal. Evaluate whether adding synthetic data improves metrics on your real validation set. If performance lifts on synthetic but drops on real, you've just found a distribution gap. Use a curriculum. Pre-train on synthetic to learn broad patterns. Then fine-tune on real data to anchor to reality. This approach often gives you the best blend of coverage and fidelity. Validate realism with both statistics and experts. Check that key marginals, correlations, and seasonality in synthetic data align with the real world. Then, ask domain experts to sanity check edge cases and rare patterns. A model that makes sense in a spreadsheet can be absurd to a practitioner. Test robustness deliberately. Use synthetic scenarios to break your model on purpose. Rare outliers, adversarial conditions, compounding errors. Don't just aim for accuracy. Check calibration, false positive trade-offs, and how performance degrades under stress. Protect privacy. Run nearest neighbor checks to ensure synthetic records aren't too close to real individuals. Consider differential privacy or other privacy-preserving techniques when the data is especially sensitive. If you cannot attest that your synthetic process reduces re-identification risk, don't ship it. Label your lineage. Tag synthetic records in your pipelines. Document generation assumptions and keep data cards. That transparency helps debugging and governance, and it prevents synthetic leakage into your final test set. Monitor in production. Even the best synthetic strategy won't save you from drift. Set up detectors, compare live distributions to training baselines, and be prepared to retrain with fresh, real data. Finally, budget for the downside. Synthetic data can save you collection costs, but it adds validation and governance costs. Plan for expert review, extra evaluation cycles, and a few iterations before you see consistent lift. Let me leave you with a few quick rules of thumb. Synthetic data is for coverage, not for truth. Use it to explore corners of the space you can't reach easily, while anchoring everything to a real, representative holdout. The more safety-critical your use case, the more you should lean on synthetic testing for extreme conditions, but the final judgment must always come from real-world evidence. For bias work, synthetic data is a tool, not a cure. Combine it with measurement, stakeholder input, and ongoing monitoring. And for privacy, treat synthetic as a privacy-enhancing technology, not a blanket guarantee. Test it the way an adversary would. If you've been burned before, you're not alone. I have the scars, and they taught me to respect the limits. Synthetic data is like a flight simulator. It won't teach you everything about flying, but it will prepare you for emergencies and help you practice without risking lives. You still need real hours in the cockpit to be ready for the sky. So the next time someone pitches a model trained purely on synthetic data with perfect validation metrics, pause and ask 3 questions. What real-world baseline did we start from? What assumptions are baked into the generator? And how does performance hold up on an untouched, real holdout set? If you can't answer those cleanly, go back and tighten your approach. Used thoughtfully, synthetic data is one of the sharpest tools we have. It helps you move fast without breaking trust, cover edge cases without risking harm, and tackle problems that would otherwise be out of reach. Treat it with respect, anchor it in reality, and it will pay you back in robustness, fairness, and speed. Thanks for hanging out for this coffee chat. If this sparked questions or you want a quick checklist for your next project, rewind and jot down the playbook steps. And remember, perfect curves in training are nice, but models earn their keep in the wild.